Here's question 1.2.12, and it's a binomial expansion problem that I would say is a legitimately hard problem. So if we start this, I'm going to give this 4 to both of these binomial pieces here. So I'll have 1 minus 2 to the x to the fourth and 2 over x squared minus 1 to the fourth. So then what I'm going to do is, well, the question is to find the independent term, and I have this whole expansion out. It's got 5 terms, and this expansion will have 5 terms, and I'm going to multiply all those together, and a couple of terms will probably cancel, and we'll be left with a few constant terms that we can all combine together. The problem is, where does it happen, and when does it happen? So I'm going to show you a little strategy here that I think is pretty helpful. I'm just going to pretend that this expansion is 1 plus x to the fourth, and this one is 1 over x squared plus 1 to the fourth. That way I can see, and I'm just dealing with exponent, or just dealing with the variable and its exponent. So then we can see when the independent term happens, and then we'll go back and fill in the numbers. So this expansion will be 1 plus something x plus something x squared plus a3x cubed plus a4x to the fourth. And this expansion, the second one, will be, well, this will get all 4 powers, so that will be let's call it b1 over x to the 8 plus b2, and this one will get 3 of them, which will be 2 to the third, which will be 6x to the sixth, and this will get 1 of them, so that'll be x to the sixth. And we'll keep going down. This will be 2 and 2, which will be x to the fourth plus x squared, and then the final, this will be 1 to the fourth, which will just be 1. Now take a look at this. We can immediately see when we're going to get some constant terms. The 1 times the 1, that'll give us a constant term. We will have this x squared times this 1 over x squared, and we'll also have this x to the a sub 4 x to the fourth times b cubed over x to the fourth. All of these 3 situations we will get a constant term. So let's figure out what those are. So I'll start with red. That's 1 times 1. This red, that's 1 times 1, which equals 1. And then the blue will have a square, this term will be, well, this is 4 choose 0, 4 choose 1, 4 choose 2, so that's 4 choose 2, and 1 to the 2, and what was the, there, and we have negative 2x to the 2, times the blue one over here is 4 choose 3. It's 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3. So this is 4 choose 3, and then we have 2 over x squared. That's a 1, and negative 1 cubed. That will be our second time we get an independent term. And then the third time, in black, we have 4 choose 4, 1 to the 0, and negative 2x to the 4. And then we'll have 4 choose 0, 1, 2, 3. That's 4 choose 3. Oh, sorry, 0, 1, 2, that's 4 choose 2, and 2 to the x, 2 divide x squared to the 2, and negative 1 to the 2. So now we just got to figure out what these whole things are. So we'll go over to our calculator, and 4 choose 2 times That's 1, and that's negative 2 squared, so that's times 4 equals 24. And then we'll go 4 choose 3, which is 4 choose 3 times 2 times, and we have a negative 1 from there. So we get negative 8. So 24 times negative 8 is negative 192. So that's equal to negative 192. And then we'll go 4 choose 4. Might be able to do this without the calculator. 4 choose 4 is 1. 2 to the 4th is 16. And 4 choose 2 is 6. 2 squared is 4. And the negative 1 squared is 1. So 24 times 16 is 384. Okay, so then we can add them all up. 1 minus 192 plus 384 is 193. So our answer is 193.